Okay, so you've learned what a wave is and that waves can travel through a medium. But not all waves transfer energy the same way. Scientists classify waves based on how they transfer their energy. We compare the direction that they cause particles to move with the direction in which the wave actually travels. So what are they? Well, we classify waves into one of two types: transverse waves or longitudinal waves. In a transverse wave, the particles move perpendicular to the direction that the wave travels in. So what does this look like? Well, have a look here. Look how the wave is moving from the left to the right, but the wave is being created using an up and down motion. The particles of the medium are only moving up and down. This is a transverse wave. Now, there are some terms you should become familiar with when learning about transverse waves. There's the crest, which is the highest point of a wave, and the trough, which is the lowest point. Now, energy can also travel when particles in a medium are compressed together and then released. This is called a longitudinal wave. Notice how the particles are moving back and forth in the same direction or parallel to the traveling wave. The part where a longitudinal wave is squeezed is called a compression, and the part of a wave where the particles are further apart is called a rarefaction. Sound waves are a great example of this. Sound is produced by vibrations. Let's say you knock on a door. Why is there sound? Well, the door transfers energy to nearby particles. The knocking generates vibrations of the molecules in the door. Those molecules collide with nearby air molecules. Then, those air molecules collide with other air molecules, carrying the energy outward until it reaches your ear. And finally, there are also water waves. Now, you may think that they are a type of transverse wave, but nope, they are actually a combination of transverse and longitudinal waves. When the wind blows, the friction between the air and the ocean causes water molecules to move up and down and forward and backwards. This causes the water molecules to move in a circular fashion. But although they move in circles, they still do not transmit matter, only energy. But wait, then how do sailboats move and surfers surf? Well, it's not because the waves transmit matter. What else could it be? Wait, the credits are rolling and he's not even going to tell us? Oh, I think he wants us to have a think, pair, share discussion in class. Oh, okay, I'll be like the best student ever and prepare and do some online research.